All right, second start. So yeah, let me know if I need to slow down. This is going to be very formal. Will this work? It will work. Je parle français aussi, mais mon langage technique est très limité. Si vous avez des questions, vous voulez que je répète en français, il n'y a pas de problème, mais ça va être en anglais. Mais bon, si jamais, n'hésitez pas. So like, if you have questions, if you have context, I don't want to stand here for like 40 minutes talking at you guys, so please just butt in, raise your hand, ask questions. It's going to make it much less awkward for me. So anyway, we're going to talk about views today. What you'll hopefully learn. So like, what are DB views? When are they useful? How to use them with Rails? I'm going to try to show you the maximum amount of code. So I'll hop into like my editor after this. I've got a repo you can follow along with, just to give you like practical examples. And my goal is really not to have this be like a tutorial, because odds are you probably don't have this need right now. But hopefully, if you do have similar needs in the future, you'll remember where to look, or at least I'll have put some ideas in your head for different options that you might have. So like, why are we talking about views? So I guess like as Andy mentioned, like I've been in and out of Rails apps for my entire career, for better or for worse. Rails really nudges you to not lean on your database too heavily. And like most of my approach throughout my career has been to like put stuff in like basically indexes and tables and not do too much else like functions or like anything else. Is just like, don't do that because you want to support multiple databases or whatever. But this is a trick that we've been using at work. I'll walk you through some examples of like concrete examples that we've implemented that like really helped us out. So like good tool to have in the toolbox. This is a thing I wished I knew like earlier in my career. So hopefully I can shortcut that learning for you and give you some context there. About me, I don't like having these slides, but for a bit of an anecdote, my first conference talk was in 2015 at Confu in the Ruby track. Yes, there was a Ruby track at Confu, hidden under the sea of PHP. But one of the pieces of feedback that I got scribbled on the back of on a note that I got given after this was like, basically, like, don't disclaim your lack of expertise, I guess is the summary of this, the nice way to put this feedback. So, yeah, like Andy was saying, I've been doing Ruby since 2009. I started in like Rails 2. I don't know if you remember like Rake Gems install. That was a lovely time. And I currently work at a climate startup called Patch. This is not a recruiting pitch because we're not hiring right now. But this is relevant though because for one, like it's a Rails shop. Two, we're a small company of like 12 engineers, and our challenges aren't scale necessarily. Our challenges are making the sense of a very complex domain and making the most of like the people we have, rather than spending time like optimizing the hell out of everything. Because in terms of like requests per second or per minute, like our app is very quiet at night. Let's just put it that way. So we're really optimizing for like ease of maintainability and that kind of thing. So yeah, back to the subject at hand. Quick disclaimer: I'm going to be talking about Postgres a lot. A bunch of these examples apply to other relational databases. I have them listed here, but like the gem I'll be using supports like MySQL, SQLite, SQL Server, and Oracle. Have bad history with 3 of those, so maybe SQLite. But anyway, you can apply this to other databases. And yeah, so like for the next like 10-15 minutes, I'm going to be talking through some code. On that repo, you have the history and the code that I'm going to be walking you through. It's going to be awkward to sit here anyway. There's also a link to the slides, so any links that you have that are on the slides, you can open later, so there's a reference there. So yeah, I'm going to attempt to switch to mirroring displays so I can do this not terribly, and we'll see how that goes. That works. All right. Is it going to complain at me? All right, let's go back to the beginning. It works. Okay, cool. I'm going to show you a base schema just because so you know what I'm talking. So like these examples aren't totally. Oh, sorry. Can everyone read? Do I need to make my font bigger font? Sorry. Where the heck is this? Here we go. 17? I don't know. I've been using RubyMine because of Thierry's recommendation for like a week now. So, excuse me. Is that big enough, or do I need to go further?
That's good.
Okay. So yeah, a base schema, just because I'm going to go through some examples, it's useful to have something semi-concrete. So I've basically gone with something like e-commerce-y because a bunch of us were at Shopify and that's an easy thing for people to wrap their heads around. Basically I have listings, so a listing would be like, I have a festival t-shirt, that listing contains several products. So products have like an inventory, price, and they belong to a listing. And then these products have properties. So I have a properties table, kind of like a tags table. These are just key values. And I have a product properties that's a many-to-many relation from products to properties. I also have some seeds. So I'm basically creating small, medium, large sizes of 3 t-shirts called red, green, and blue. I will show you this in a second. So let me just migrate. And I will seed. And you'll see, so I have a bunch of models here. These like basically exactly what you would expect, nothing too surprising. I did add though, sorry, that's my model. If I go to my next commit, you see I've added an overview. So let me just show you that quickly so you know what data exists. And that's basically what I was talking about. So this is the data we have in our database. I have a red t-shirt listing. That's listing 1. It's like, and these are the tags I was talking about. So color red, size small, and so on and so forth. And yeah, that's basically it. Like I said, any questions, always good. All right, let's hop to the next commit. So imagine we have that schema and we want to show you, so we had like an inventory on the product. We had a bunch of properties. We want to show you in-stock products of a certain color, for example. So you might implement this, here, I added 2 methods here. So I'll show you quickly what these are doing. So I added an in-stock scope. There's different ways to do this. This is the first thing that came to mind, but I have an in-stock scope. This basically looks for in-stock listings and then does like an inner join. This is a relatively new Rails feature where you can do common table expressions, but basically it makes this query available inside of this query. And so I'm taking all of my listings and then inner joining on this subquery to get the in-stock listings. And then I did a similar approach with property. Same thing, basically find the relevant properties, do an inner join on the listings, and so now I can combine these in interesting ways. So if I wanted to say, give me all the products that are blue, give me all the listings that, so like in stock. Well, did I not? Yeah, sorry. Typing while presenting, not my forte. Thank you, Charles. Yeah, so those are my 3 in-stock listings. And then I can chain these. So I can do with property. Let's find a property value. It's gone off the screen. Blue. And then I've got my blue t-shirt, which is in stock. I bring this up because this is the kind of your product manager tends to come with you and says like, what if we had a search experience and like we're just going to do sizes and colors, it's going to be great. And then this inevitably becomes like a giant mess. And eventually you want to add more attributes, and that means like every time you maintain this code, you have to think about like all these inner joins. There's different ways to implement this, but obviously like you could see like every time I add a new like dimension to filter my like listings on, I end up with I end up like accumulating this giant like SQL query that's doing like all these joins or like manipulations, and then you have a hard time reasoning about cardinality and things like that. So one thing you can do to like potentially solve this, which is where like views come in. What did I do? Oh, I'm in the console. Thank you, John. So first thing, I'm going to be using a gem called Scenic. I won't show you a gem file because it's a gem file and you've probably seen that before, but where's my Firefox? If I open Firefox, this used to be part of Thoughtbot, got spun off into its own org, but it's a very well maintained library that lets you deal with managed database views from your Rails app. You basically run this. So I've already done this in the next commit, but I generate a Scenic view and then you give it a name. So if I hop over to my next commit and I show RMS. So I created a new, it generates a migration for you, and this looks very empty, but you'll see it basically creating a view named listing search results. And then it also creates a listing search results. So you get this new folder here in DB called DB views, and that basically has all your the name of your view and the version. And so I've created a new view here, and basically this is a big SQL query. I'm doing similar things that I was doing earlier in the model, but basically I put it basically dumped it out here. And now if I DB migrate, look at that, and I open my database viewer and reload. I'm in the wrong database. Here we go. You'll see this blue table here. And this blue table is basically the output of that query. If I look at I probably make this bigger for the people at the back. This actually works with the thing you hope. If I look at the definition here, so this is a view, and this is the exact SQL that I dumped into that v01. But I can interact with it from a query perspective. I can do like select from listing the complete. Yay. I can interact with it like a view, basically. Sorry, I can interact with it like a table, but it's underneath. It's just an SQL query. But it lets me hide all this complexity behind this and pretend that I have a nice condensed one row per result kind of solution. So I just have a Boolean for in stock, and I have my property IDs for each listing. Did I have anything else in here? Oh, right. Yes. So the other thing you can do, because it looks like a table, is I could do a listing search results. So I added this model. And this, from a Rails' perspective, is just a regular old model. It behaves exactly the same way. So it's back to, you can have relations. So because I have a listing ID on in the output of my query, I can just have it be a relation. This here is an they recommend you do this. You don't really have to, but it prevents you from trying to save on it because it's a view, and you'll probably get a Postgres error if you do anyway. So this lets you fail early. But here you'll see that I've now implemented what I had before on listings in a much simpler way, where now I can just say, okay, well, if I want in stock items, I could just do in stock true. If I want with a property, I can just do an array index of here. And this, this is probably this is where I started using views a lot more heavily, in that we had a page like this that was faceted searching, and we had a lot of logic for this kinds of filtering, and it's a lot easier to reason about when you're just appending wheres to existing columns. That way you don't have to think about where the data came from. You can review and test and make sure that your query is correct, but then in your actual querying logic, you can simplify that quite a bit. So sorry, that's all. That was the end of my sentence. Let's go to next. So the other thing you can do the other thing Scenic likes you to do is obviously your view is not set in stone, and you might want to evolve it over time. So if I open this, I basically, if you rerun the same generate command, so the Rails generate Scenic view with the exact same name, it'll do an update for you. So if I look at the migrations, I'll have a new migration here. This does update view. You'll see it's the same name, but now I have a version 2, and I can revert to version 1. And that basically, I made some changes in here. So instead of, I added min price and max price, because for every listing there could be multiple products. If I then migrate this, I'll get my second version added to my database. And so if I look at here, if I reload this and I re-execute this, what did I do? Let's look at the contents. There we go. So now I have my min price and my max price, and I was able to evolve my schema over time by just adding additional versions to my views. And again, these just act like models. So I'm using the annotate gem, but you'll see the prices show up here. And from the rest of my app, it looks like a regular old model. The other thing I can do, so far you've seen me create a non-materialized view. So that basically behaves like a query. It just look you can create a table, but under the hood it's just a subselect. If you look at your query planner, you do an explain, you will get basically the output of that query underneath your whatever you're injecting at the top. But what you can do, so the other type of view that you can do is called a materialized view, which is where you basically tell your database to put the output of your view into an actual table. And so it'll just create, it'll execute whatever query you give it and then store it the exact same way as any other table. This is actually really straightforward to switch to. So this is another thing we've done as well, is we'll start out with a regular view. Eventually, from a query perspective, we want it to behave more like a table. So we'll switch it to a materialized view. There's different trade-offs I'll go into, but I'll just show you how that's done. So here, and then if I look at, there's a new migration that I created. This is a bit more involved because there's no like one method thing to switch to a materialized view, but if you look at, this is pretty straightforward. So I'm dropping my existing view and I'm creating the exact same version. So at this point I was at version 2, I'm just recreating version 2, but I'm adding this materialized true at the end. A huge benefit of materialized views is you can add indexes. So you're seeing me add a listing ID unique index here. I'll get into why that's important. And I'm also adding a property IDs, which was in my array of properties, because you can do cool things in Postgres, like there's the gen type index, which is the generalized inverted index, I want to say. But you can speed up like array lookups and that kind of thing using like different types of indexes in Postgres. You could do full text search and that kind of thing here. So that basically switches this migration basically switches the table type. If I then migrate and go back to my database, you'll see it switches, I don't know if you could tell with the color, but it switched from blue to green in Postico, which is helpful. But basically the same thing, but now if I look at the structure, it says a materialized view, and I'm getting the same data, but now this data is on disk, and I have indexes on it. So I have it in list. So like if I were to query by listing ID, I'd be using this unique index here, or if I'd be querying on the property IDs, I could use that index there. The reason I mentioned the unique index on property ID, the listing ID is, if I go back to my listing search results. So the way, how do I undo that? There we go. So the way materialized views work is they're a one-time creation, so you have to keep them up to date. And the way you would do that, so Scenic also gives you like a helper here, so you can do basically what I'm doing exactly here. So you basically refresh the materialized view. That basically tells Postgres to re-execute your query and update the table. And what you want to be doing, so like this is why I added the unique index, is you want to be using the concurrently option, because if you don't do that, it'll lock the entire table, which is generally not great for your app. But if you have a unique index that covers the table, it can do this concurrently. So yeah, you're still executing the query, but you can still send read traffic to the the previous data, and this will continue to work fine. I can show you how. It's calling a method, but let's see. There should be some Postgres output, which might be so. Listing search results dot refresh. And yeah, this is what it's executing. It took 14.2 milliseconds. Cool. We do this, so when I talk into like the specific examples, like we do this in the cron. Some tables it's every 5 minutes, some tables it's once a day. It really depends on like your tolerance for stale data. For use cases like I just showed you, where you're basically generating like a search document and you want to like filter over it, usually people are more tolerant to something being out of date for 5 minutes. Or even more, so like up to you how you want to do this. So like it is a trade-off. The benefit is that like you're dealing with a table versus dealing with like having to fetch all the stuff that your query defines. Let's see what's next. I think that's all of it. What did I do here? I added slides. Okay, so I can go back to my other one. Any questions before I switch back to my slides?
Stupid question. What's JJ next mean?
We could talk after, but the short version is it's a experimental version control system by a guy at Google. It pretends to be Git under the hood, so you can just use it while your colleagues are totally unaware, and it has a lot of cool features. But we could talk after. That could be a talk in itself, but yeah.
I have a question too. Is like materialized view, you cannot keep them up to date by themselves. You have to explicitly refresh. I thought you could, but Postgres would be able, when you insert from in the source table to just.
So there's no first party option. There's been like on the Postgres mailing list, they've like talked about this, and there's been like various like academic research on like how to do it efficiently. So there is interest in this. I link to the wiki later, and there's also a like third-party extension that does this. The downside is like we use RDS and like, sorry, but there are, and do exactly what you say, where they look at your query and then put hooks on the right tables.
Like denormalization, so you're paying more for your writes, but then your reads are easier.
So there are options to make it either. I think in that extension you can do it like in the transaction or like after the commit. So there are options, but if you're using out-of-the-box Postgres, you have to manually refresh your views.
You could use triggers.
But then you're gonna spend a long time on it. It's probably gonna be
probably
full of
not
bugs.
efficient. So.
Yeah, the reason, I think the big benefit is that like you're using a thing that's out of the box. You don't have to write any synchronization codes. You don't have to maintain triggers. It's just like a query, which has a lot of benefits for like small startups. If you don't want to, if you don't want to maintain all that infrastructure. I'm gonna attempt to switch back to my slides if that works.
And just to clarify, when you have a view, so it's running that, if it's not a materialized view, it's running that SQL on every single query to filter it, correct?
Correct. Yeah. Basically, if you were to rewrite it where you did your query and then from, and then in a subselect you pasted the view definition, that's the performance that you would get basically for that view.
Got it. Even though it's a native database feature.
Yeah. So you get some benefit in the sense that like, I think the query planner is a bit smarter, and because it knows like it's like it acts like a prepared query basically because it's in the database. But like beyond that, if you need a mental model, you have to think about it as like a full. Like, you're not saving anything. What you're getting is like abstraction, which can be useful for. Like we use it for like analytical queries. Like if I want to give finance a way to like not have to think about our application modeling, but like generate some report. Like I'm running on a replica. I don't care how long it's going to take, but like they just have a nice table that like I don't have to maintain. So it's a bit like good use case for that. Let me find my slides, which have disappeared. Will they come back? Hey, look at that. All right. All right. To recap. So yeah. Views, like I said, views are a way to turn an SQL query into something that quacks like a table. Like we were just discussing, they behave like a subquery from a performance perspective. And you can put a standard model in front of them. You can also test them the same way. So if you're using something like FactoryBot, you can like create the records that would have been pulled into that query and like basically write a standard test, which is really useful if you want to like make something maintainable that you know is correct, then other parts of your code can use. And like we saw, you can use it with the Scenic gem, which is by far the easiest way to do it in Rails, although you can put like raw SQL in your like migrations if you want, but not really, no good reasons to do that. Materialized views, similar concept, but like they're written to disk. They behave like a real table because you are actually like storing bytes on disk. They can be indexed, but they need periodic refreshing. And like I said, they can be refreshed concurrently if you have a unique index, but like I would consider this a must because if you're not doing that, then like unless your app is basically doing nothing, that becomes a bit problematic. So I mentioned I would talk about a few examples from our actual app because I think that's more useful here. The first one is we have, for legacy reasons, we actually have like two versions of like an object that represents a sale to like a human. One is called sales, the other one's called orders. Of course, at some point we wanted to show like a cohesive list to a user because that seems like a basic requirement. So we basically have this thing called unified sales. In SQL, you can just union all two tables. You can index them. So we have a materialized view called unified sales, and that's basically the main listing of sales for our customers. The advantage there is because it's a real table, you can paginate it, you can index it. So like the performance is a lot more predictable. And from a data freshness perspective, like so far we haven't these two models are being written to they involve like human processes, so they're not being written to that often. For a while we just like if you did update a sale we regenerate the view, but now we just run it every 5 minutes. Not a big deal, but really helped us avoid having to write like a really expensive migration to like a unified model. Someone spent an afternoon writing this query, we like tested it, and then now we have a model called unified sales that we can use to like pretend that everything is fine. And so far so good. Second example, so this is the other examples I talked to you about, although this is real things that we pull into our actual like search records. You could be, so like the reason I brought up the context that like we're a small team, we're trying to use like the tools we have, like in like my like default to solving this kind of problem would be to index into like Elasticsearch or something that does like multi-dimensional like querying. But like that's yet another system. Like you have to deal with like batching or like on dev setups, they have to have like Elasticsearch installed. In AWS, you need a new service. In this case, we basically like pulled everything that we could possibly want. Like again, this was me figuring out like, okay, you're gonna want to filter by like these things, and like writing a big query that like pulled all of that data into like one big table, and that basically let us like express like the previous version of this feature. Several very smart people basically abandoned trying to make changes to it because we couldn't make heads or tails of like what exactly you filtering and are your like results correct. Whereas With this approach, we were able to validate that the query was correct, and then we basically expressed the filtering logic as wheres on like single rows, which is a lot easier to reason about and a lot easier for people to like iterate on. The last example I'll talk about is providing, like I mentioned to someone earlier, but like providing useful abstractions. Oftentimes, like you'll have different parts of your app do different things, but like being a Rails app, like everyone has access to all the tables, and maybe you don't want to like split, like have the same logic about like reasoning about like one domain and another domain. So having like a view basically pretend to be a nice version to like mask a bunch of like details behind like part of the app is very useful. For a concrete example, like we model the like, we don't do it anymore, but we used to have a product to help carbon credit suppliers basically manage the life cycle of their projects. The way you think about inventory as a carbon credit supplier is like, so carbon credits are issued per year. You kind of choose what an issuance is basically you going to a registry and saying like, I worked on this is my data, this is how long I measured for, can you issue carbon credits for me? And then they get credits for every vintage. There's also the notion of like, well, some of this is forecast, that's issued. Those are different things from an inventory perspective. In the part of the app where suppliers were interacting with their inventory, like we want this level of detail because like that's how they're thinking about it. But in a dashboard in the other part of the app, or if we are like purely from a sales perspective, like you're just thinking about, like you're not thinking about inventory, you're thinking about like what is available for sale. Like you don't want to deal with like all of this. And what ended up happening in our app was the logic to reason about this and to basically get aggregate numbers per year ended up like being replicated in like 3-4 different places, sometimes incorrectly. And that becomes a major headache because you don't really find out about it until like someone's on the phone with you being like, well, on this screen it says that, and on that screen it says this number, like what gives? And you spend like a bad afternoon. So our solution to this is this is one example, but we have a lot of these throughout the app where we take all of this mess and create a thing called project vintage inventories, which gives you like a project, a vintage, the number of issued credits, the number of unissued credits, and that way like the rest of the app can interact with this whole inventory tracking system as like a nice table with like exactly what you need, and you don't have to think about the underlying details. Also a useful way to do refactors. If you want to like change the backing of like some of this, you can like decouple parts of the app by having a view, and then you can just change where the viewpoints over time. This has happened several points in our like inventory search records where we were able to evolve the app underneath it, and we basically updated the view, and then the rest of the app doesn't have to care. So like in broad strokes, great tool to dry up your code base and basically hide a bunch of complex like logic behind like a nice like abstraction. And then the second point, which I was saying about like smaller startups and stuff like that, is you can really like you can basically get yourself more runway or like more time before you need to throw in like big tools or synchronization or like Elasticsearch or like other ETLs. You can basically use what you already have to create a search document, or basically take the data you have, transform it some other way, and like you can get a lot of like use out of this kind of thing. If you want a real example, I won't show it to you, but Mastodon actually uses Scenic for recommendations and stuff like that. If you click on that link in the slides in the thing, they'll take you to their actual repo. They have the exact same setup. They use it, I think the example I linked to is they use it to like rank like follow recommendations. So they basically run it once a day. You have follow recommendations, and they're able to like query that table to say like, give me 3 IDs to show in some page, and like the code that shows the IDs doesn't have to care. And like those of you who followed the growth of Mastodon will probably know well, for me, I just like witnessed the world learn how to like maintain Rails apps, which was like funny but also painful. And so the more they can do to like use fewer things, I think the better, because not everyone's like the biggest instances, and a lot of people are like it's just a lot to handle. So what are the trade-offs? I mentioned some of these, but it's worth like repeating. So they're only the regular views, like non-materialized views, they're only as performant as the queries that define them. And like basically you're still at the whims of the planner, the query planner. So your solution here is to measure. This might work out for like an analytical query where you don't care about the response time. If you're using this on a like performance critical part of your app. If your underlying query is super simple and can just be like load from an index, then your view is going to be fast. It really depends on what you're doing with it. It can also make it super easy to like paper over mountains of complexity. Like in some cases, which thankfully we've cleaned up since we had views calling views calling views. And then your like query plans look like an Alexander Calder mobile. Points for art references, but this is literally what like Datadog would look like for some of these things. And then I had to go like be the defender of the database and be like, what the heck are you doing? But it's because it looks like a table, people don't think twice about querying it. And like, you just have to know it's a spicy table. And like, sometimes it can be really slow, but like it's an abstraction. Sometimes that abstraction comes to bite you. And then for materialized views, so they're a lot easier to reason about for reads because you're dealing with a real table. But yeah, then your like scaling factor is refreshes. So like, because you're doing this whole query and like rewriting a whole table, like that's the load on your database. If there's not a ton of load, you have headroom, that's not a problem. Eventually, if you're dealing with like, tens of millions of rows, this becomes taxing. That might affect like, take resources away from like other queries. So something to bear in mind. The last thing is like I mentioned, stale data. So you have to refresh your data. And to Jean's question, like PGIVM is the third-party like plugin that will let you do incremental view. What is M? I don't know, but that's what it stands for. And I linked to the wiki on the Postgres wiki of like talks of bringing something like this into the database. But at the moment, if you're using box standard Postgres, you'll basically have to run your like refresh on a cron. So trade-offs. I just want to touch on like performance because like this is something I had to unlearn going from like big company to small company. Is that you're not Shopify, so like if your view is a bit slow, like your database is probably fine, and like you have a lot more leeway than you think. And like humans are expensive, so like if you want to spend time like writing synchronization logic and spinning up like new infrastructure, that's a lot of overhead. If you can get away with things like views with like what you already have, and it will buy you time to figure out, in our case, to figure out like product market fit, and then like people in 5 years can like who like in a company that's hopefully making like way more money can like fix this and like build other systems. But at least like they'll have a nice query and a nice model that they can go off of, and it'll be easier to understand. So, but yeah, and then lastly, like measure. I have a extra slide just to show you a tool that I really like, but like all of this they're all trade-offs. There's no like easy solution. I am not going to pitch you this as like solving everything. They're cheap to create, so like dump one on your production database if you have a replica or if you have like a read-only connection. See what it does, like measure. There's probably indexes you can add. There are probably optimizations you can do. I can't give you a solution, but ultimately like your success here is going to depend on your use cases, and like the performance of it will depend on like what queries you're running and all of that. Some annoyances to keep in mind. Again, not a tutorial, but like if I say this to you, you'll be like, if you ever end up using this will like flip a light switch in your head somewhere, and you'll be like, oh yeah, this is a problem. It's annoying. So the first one is, yes, you can't, if you're changing a view that depends on other views, you have to drop the other views first, create your new view, recreate the other views. This is more of an annoyance. You can do this in your migration. Not a super big deal, but something to be aware of if you are evolving your view schemas. The second one, a bit of a bigger deal, like if you're working on teams, but the way Scenic is set up, you basically create your table, but there's nothing, and it like applies your view definition to your table, but there's nothing in the table itself to tell you like what version you're running. And this becomes a bit of a problem if you and your colleague are working on like iterations of that view at the same time. You could end up with like two of the same version and like migrations that like, and like your merge conflict won't make any sense because you're making like different things to like a new version, and like, so basically what you end up having to do is like accept that someone is like going to go first and then rewrite your changes on top of their changes so that there's a nice like serial 1, 2, 3, 4, and you can apply your migrations. You can backtrack based on the Rails like version number, so that'll tell you like what was run. But in terms of like development flows and version control, this is something to bear in mind as well. Lastly, yeah, so when you create your view, Postgres will freeze the like schema in time. And so if you change a backing table, like say you add a column to a backing table and you're doing like a select star in your view, that new column is not going to appear until you drop and recreate the view. Something to bear in mind because it can be a bit frustrating. So a bit of additional complexity you have to be aware of if you're like relying on these pretty heavily. I'm going to stop there. I have a couple extra slides, but before I switch to that, any questions, comments?
Can we see your schema?
Which one?
The one from your examples?
Sure. It's in the repo. I don't know if I can. Let me see. It's here, and then I can just show you. I think this will work. Is it gonna work? Come on, GitHub. Ah, crap, I'm not online. All right. Let me, do you mind if I go back to it afterwards? It's in like,
Is it there in this code then?
oh, it's here. Sorry, my slides went away. Yeah, there you go. Where's my, if I can find my mouse, I swear. DB schema. Oh yeah, so one thing I didn't mention, I can move this away, go. So yeah, one thing I didn't mention, this ends up appearing as like create view in your schema. Basically, Scenic adds these methods to like the schema definition. And so these just end up in your schema and you get the full definition here.
Yeah, to me that's one of the annoyances. It's like having that in my schema.
I mean, how often do you read your schema?
No, I don't. It's just having that chunk, and I don't know. It's just I would rather having it there and referenced in the schema.
Because it's reusable.
Yeah, it's the full view, right?
Yeah, it's full view, yeah. It's a full query that you're doing. I mean, what we do is like, so there's, yeah, and that could be an annoyance, especially because at work, we run Postgres 12 in production, but everyone, there's basically, in development environments, there's a sliding scale of when they ran like brew install Postgres, when they like join the company. And like the like output of the schema definition is different, subtly different, but still compatible between all the Postgres versions. And so every time you run a migration, someone just like creates a giant diff for nothing, and like that's really annoying. But one thing we do to like, because I don't stare at my schema that much, but like if you use the like annotate gem, you just get these nice comments at the top, so you don't have to care. Like this is most like once you have this, like most of us use that as a reference for like what the heck is my table rather than like the schema itself, because yeah, it's like you said, giant pile of SQL, so not that useful. Any other questions?
Do you know if refreshing materialized view happens in a locking transaction? Like, what happens if you're trying to read that view as it gets refreshed?
If you're trying to read it, if you're reading it,
a snapshot change all at once, or
if you're running it non-concurrently, it'll lock the whole table. So whatever you're doing is going to wait. If you run it concurrently, it applies the same way as like someone writing to the table row by row. So you'll get whatever.
So you could query midway.
Yeah, you could query midway. Yeah.
Okay.
In general, I wouldn't recommend views for like writes. Like if you're reading from it for a write, because of if it's a non-materialized view, then whatever, it's a query. If it's a materialized view, then you're gonna have to deal with the fact that it's like stale. And so if you're relying on it to join things and to like, especially like if you're reading and writing.
Stale and inconsistent might be different kind of problems.
Oh yeah, if you're midway through a refresh, that also could also.
But I guess you
yeah.
can do the LHM thing where you create a new.
You could do that, yeah.
A new materials you want to.
Yeah, and like atomic rename.
Atomic rewrite. And
Yeah.
But
This has yet to be a problem for us. Yeah, and like I said, and like if you're using this and you're running to that problem, like maybe this isn't the right solution for you. I think like most of our view paths are like our reads, so this simplifies a lot of our read paths. But if you're relying on it for things like that, like it might be more of a problem. Yeah.
Could you speak to using views to solve really heavy joins in mid-sized Rails apps? So like for us, we have like, it's not many records, we have hundreds of thousands of records. And we have kind of what you described earlier, where it's like credits, debits, tons of stuff like that. And we have a handful of queries that just take forever to run. They're very heavy. If you were in our shoes, how do you think about using views as a potential solution for that?
I mean, the thing we do with, if I go back to here, and I go back to, where was it? Where are my examples? Here we go. Does that do something? Here. There we go. Yeah, so this is actually a similar case where like both of these are pretty like what we need to do to like obtain like unified sales is quite complex because all of these have like relations in both directions. The trade-off you're paying for, so like yes, it can speed that up in the sense that like you get a table at the end, and that table is like on disk and can be indexed, so you're basically reading as if like you're reading from like a regular table, with the trade-off of like potentially having like stale data because you do have to refresh it. So in our case, like that was acceptable in this case, but might not be a solution if you have if you need like absolutely fresh data every time. Anyone else? Cool. So I had a couple extra slides and then I'm done, I promise. Yeah, so bonus use case, 1, extra slides. Something to be aware of, but you can use, so in Postgres, I don't know if this is the case in other databases, Simple views you can write to them. If they have like you're allowed wheres, you're allowed different things. But one actually practical use case is if you need to rename a table and you don't want to take downtime, you can create a view with depends. You can do it in both orders, but like rename your table, create a view, name it with the old name pointing to like the new table, and that will behave the same way as the other table. They're just two names, so long as you don't change your schema in the time you're migrating. But if you're changing the name, I don't think you're changing your schema as well. But if you want to like if you want a zero downtime like table rename, that's a really useful blog post that explains this pattern, but a useful way to do it. The other thing I will show you is this repo, which is, I don't have internet, but I had it offline. I think it's here. But basically, at this repo, you will find a pile of HTML that you can just download. So I'm loading it from my downloads folder here. And this thing is a Postgres explain visualizer. And so if you go to, this is an old plan that I'm showing you, but basically if you go to here, you basically slap that at the beginning of your query, and you can run that on Postgres. You'll get some JSON out. If you paste the JSON in, you get a nice visualization like this. This is a very poor example because this whole query took less than a millisecond. And so one thing to bear in mind with this tool is everything is proportional. So if it's a really fast query, this looks really terrible because it's very red. But like, you shouldn't care about this because like overall it's fast enough. But if you're optimizing things like views, or like if optimizing your like, even like in the case of Materializer, you're optimizing your definition. Like this thing is a godsend. You can basically look at like by duration, by number of rows. This is really teeny, but there's options over here. And then you can like zoom in and say like, oh, okay, this is the query I used, I think, for the view. But you can see like what the heck it's doing and in what order, what indexes it's using, and basically see like from the database's perspective, what is it taking to like actually like return that query. This is where my Alexander Calder like mobile like metaphor came back. Is that like I've had some that really like if I showed you the whole thing, they wouldn't fit on the page. So that's where like you can take these too far. Something to bear in mind. And yeah, that's it. That's my whole talk. I had a slide with my socials, but I don't care. It's fine. But anyway, questions, feedback.